2's complement is actually used to represent negative numbers in binary system. Now let's look at an example. Let's say I write 2's complement here. Let's say you want to find the value for -7. How do you find it? You can convert the 7 into 2's complement, and that's going to be the -7. So let's do this. Let's say I want to express this one in a 4-bit system. In 4 bits, we're going to have 2 power n minus 1, that is 2 power 4 minus 1, that's 2 power 3. So we are going to have 2 power 3, 2 power 2, 2 power 1, 2 power 0, 8, 4, 2, 1. So here for the 7, we will have 4, 2, and 1. So this is 1, 1, 1 here, and this 0. So the binary conversion of 7 is 0, 1, 1, 1 in the 3 bits, actually 4 bits. Now what we do is we take the 1's complement. 1's complement is actually the flip of this. Like we change the zeros into 1 and we change the 1's into 0. So this is going to be 1, 0, 0, 0. And to find the 2's complement, what we do is we add 1 to this. We add 1 to this one. That's going to give us 2's complement. 1, 0, 0, 1. And that is 2's complement. And this one represents -7. So -7 is equivalent to 1, 0, 0, 1. Now how you can quickly check whether it's right or not? Now we know that in 2's complement, the first number is actually associated with negative value. And if you look at our binary system, the weight of the first number here is 8 and then 4, 2, 1. 8 is the weight of the first number. So you have to just make it minus. So this is -8 and we have a 1 here. And if you add them together, you're going to get -7. That's how we can quickly verify whether you got the right answer. Now let's look at another example. Let's say you want to find out, you want to express -12. Again, you have to do the 2's complement because this is a negative number. You can do that with 2's complement to express -12. Now let's look at 12 first. 12 in the 4 bits number system, 8 plus 4, that is 12. So 1 plus 1, 1, 0, 0. So you can write 1, 1, 0, 0 for 12 in binary conversion. Then what you do is you take 1's complement. 1's complement is basically the flip of this. So this is going to become 0, 0, 1, 1. And then what you do, you add 1 to this to make it 2's complement. Add plus 1. So when you add 1, 1 plus 1, that is 0. 1 plus 1, that is 0 and a carry 1. And then 1 plus 1, 0 again, carry 1 here. And then here we have 0. So okay, you know what, let me double check. 8 plus 4 is 12. Yeah, 8 plus 4 is 12. And I took the 1's complement, that is 0, 0, 0, 1, 1. And we have we added 1 to this, that gives us 0 here, and I carry 1, 1 plus 1, 0, then 0. Okay. So the final answer here is 0, 1, 1, 0, 1, 0, 0. That is our 2's complement. Okay. Let's look at an example of, let me double check again, like 12 is 8 plus 4. So we put 1 1 0 0. We took 1 0. We took 1's complement, that's flip of this, 0 0 1 1, and add 1 to that, that is 0 here, carry 1, 1 plus 1, that is 0, and then we have 1, 1 here, and then 0. Yeah, so this is the 2's complement of 12, that's minus 12. Okay, now let's do some addition. Like, the 2's complement is helpful to addition, because if you look at my last video, I talked about sign numbers, but sign numbers is easier method to express negative numbers. But when we do the addition, it's not going to help. It gives the wrong answers. That's why we use 2's complement, because it will be helpful for us to do the additions with the negative numbers. Now we can also do it without having the 2's complement. Now let's look at an addition. Like, let's look at an addition with negative number without 2's complement. So let's say we want to add two numbers. One of the number is negative, one of the number is positive. Let's write some values. 0 1 0 0 1 1 1 0 0 1 1 0 0 1. Now we can also say this subtraction. Okay, when you're adding a like 7 minus 7, also same as 7 plus minus 7. So we can just do subtraction here. This is not 7, but I just illustrate this on what you are doing here. Okay, let's do the subtraction. Okay, when you do the subtraction in binary, you have to be a little bit careful. Here we have 1 minus 1, that is 0. You have to be careful when we get negative numbers. 1 minus 1, that is 0. 1 minus 0, that is 1. 1 minus 0, that is 1. And then 0 minus 1. Here we have a negative 1. So we have to borrow. We cannot borrow from this one because this one also 0. But we can borrow from this one. To borrow from this one, what you have to do is we have to borrow from here to here, then here to here. So if you borrow from here to here, what's going to happen? This becomes 2. You can also put 1 1. That's going to be a lot of confusing, but better to put 2 to illustrate this one better. Then you take 1 from this, and that's going to be 2 here. Okay, whenever you cancel a 0, you put a 2. If you remember that, you're going to be good with this. So you put 2 here, and 2 minus 1, that's going to be 1 here. And then we already got 1 from this, so we have just 1 here. So 1 minus 1, that's 0. And we took this 1 already, so there's nothing there, so that's 0 0. So this is actually the number we got by subtracting this one from this. Now let's actually see in decimal whether this is actually correct. Now this is how many numbers. We know that in binary number system, the first number carries the weight of 2 power 0, 2 power 1, second number 2 power 1, third number 2 power 2, fourth number 2 power 3, fifth number 2 power 4, sixth number 2 power 5, and then seventh number 2 power 6. Now you have to just look at the numbers that is with 1. So here 2 power 0 has a 1, so that's a 1. And then 2 power 1 has a 1, that is 2. 2 power 2 has a 1, that is 4. And then 2 power 5 also has a 1, that is 32. And for the second number we have, okay, let's actually find out what is this number. 32 plus 4, that is 36. 36 plus 2, 38. 38 plus 1, 39. And let's look at this number. We have 1 at 2 power 0, that's 1. And then we have 1 at 2 power 3, that is 8. And we have 1 at 2 power 4, that is 16. And that's it. So 16 plus 8, 16 plus 8 is 24. 24 plus 1, 25. And we are subtracting 39 minus 25. If we do that, we should get 4 here and 1 here, 14. Is it 14? Let's actually see. 2 power, we have a 2 power 1, that is 2. And we have a 2 power 2, that is 4. And we have a 2 power 3, that is 8. 8 plus 4, 12. 12 plus 2, 14. So this one actually works. But you can do the same thing with 2's complement. Let's actually see that in my next video. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.